Good morning, everyone. I'm Mrs. Janson, and I'm back for the final lesson for Quarter 1 in Grade 8 Mathematics. We are now in week number 8 with the topic, Solutions of Systems of Linear Equations in Two Variables. In this lesson, you are expected to solve a system of linear equations in two variables by graphing, by substitution, and by elimination. Recall, the ordered pair that satisfy the given equation in two variables is called the solution of the equation. Example, this is the graph of x plus y equals 5. All the points within the line are the solution of the equation x plus y equals 5. Let us define system of linear equations. System of linear equations contains two or more linear equations. There is only one unique solution or ordered pair that will satisfy both equations. Example, the ordered pair 1, 2 is the solution of the two given equations, which are y plus x equals 3 and y minus x equals 1. In solving a system of linear equations, there could be one solution, no solution, or infinitely many solutions. Learning task number 1. Which of the following graphs has one solution, no solution, or infinite solutions? For graph number 1, the system has no solution. As you can see, the graph consists of parallel lines. For graph number 2, it has one solution because the lines meet at exactly one point, hence they are intersecting lines. For graph number 3, the system has an infinite solution and it consists of coinciding lines. Finding the solution of system of equation can be done in different ways. It may be done by graphing, by substitution, and by elimination. Let us begin with the solution of system of linear equation by graphing. Illustrative example. Graph the equations in one coordinate plane, negative 2x plus y equals 2 and negative x plus y equals negative 1. The graph of negative 2x plus y equals 2 is the red line, and the graph of negative x plus y equals negative 1 is the blue line. The two lines intersect in negative 3, negative 4, which is the solution to the system of equations. Now, we proceed to solving systems of linear equations by substitution. Here are the steps. Step 1. Solve for one variable in one of the equation. Step 2. Substitute the resulting expression into the other equation. Step 3. Solve the equation to get the value of the variable. Step 4. Substitute the value to any of the original equation to solve. And step 5. Write the values from steps 3 and 4 as an ordered pair x, y, and check. Solve the following system of linear equation by substitution. Given negative 2x plus y equals 2 as equation 1 and negative x plus y equals negative 1 as equation 2. Step 1. Using equation 2, which is negative x plus y equals negative 1, solve for y and we get y equals x minus 1 and this becomes equation 3. Step 2. Substitute equation 3 to equation 1. Equation 1 is negative 2x plus y equals 2. The value of y in equation 3 is x minus 1, so substitute y with x minus 1 in equation 1. We get negative 2x plus the quantity x minus 1 equals 2. Step number 3. Solve for x, so we have negative 2x plus x minus 1 equals 2. And then combine like terms. Negative 2x plus x is negative x minus 1 equals 2. Adding 1 to both sides, we get negative x equals 3. Then multiplying -1 to both sides to make x positive, we have x equals -3. Step number 4. Substitute the value of x to equation 1. Again, equation 1 is -2x plus y equals 2. Substitute x with -3, so we have -2 times -3 plus y equals 2. -2 times -3 is 6 plus y equals 2. And then adding -6 to both sides, so we have y equals 2 minus 6 or y equals -4. Step number 5. The solution is -3, -4. The value of x is -3 and the value of y is -4. Checking. Substitute the solution to both equations. For equation 1, which is -2x plus y equals 2, substitute x with -3 and y with -4. So we have -2 times -3 plus -4 equals 2. -2 times -3 is +6 plus -4 equals 2. So 6 plus -4 is +2, which is equal to +2. So therefore, equation 1 or the first equation is being satisfied by -3, -4. And then for equation 2, -x plus y equals -1. Again, substitute x with -3 and y with -4. So negative of -3 is +3 plus -4 we have -1. So they are also equal. So therefore, the solution -3, -4 is true for the both equations. Now, we proceed to solving system of linear equation by elimination. Here are the steps. Step 1. Write the system so that the like terms are aligned. See to it that the variable to be eliminated have the same numerical coefficients, otherwise multiply both. Step number 2. Eliminate one of the variables and solve for the other variable by addition or subtraction. Step 3. Substitute the value solved to any of the original equations. Step 4. Write the results in steps 2 and 3 as an ordered pair x, y, and check. Illustrative example. Solve the following system of linear equation by elimination. So equation 1 is -2x plus y equals 2. Equation 2 is -x plus y equals -1. So step 1, so you may write the two given equations vertically so that like terms will be aligned. So we have -2x plus y equals 2 and -x plus y equals -1. Step 2, subtract the equations to eliminate y since they have the same numerical coefficients. So in subtracting polynomials, we change the sign of the subtrahend. So -x plus y equals -1 will be changed into +x, -y, and +1. So -2x plus x is -x, and then y will be cancelled because the result will be 0, y minus y. And then 2 plus 1 becomes 3. Now, to make the variable x positive, multiply both sides by -1. So we have x equals -3. Step 3, substitute the value of x to any of the original equation. For equation 1, -2x plus y equals 2, substitute x with -3. So -2 times -3 is +6 plus y equals 2. And then subtracting 6 to both sides, so we have y equals 2 minus 6 or -4. And then for equation 2, -x plus y equals -1. Again, substitute x with -3. So negative of -3 is +3 plus y equals -1. And then subtracting 3 to both sides, so we have y equals -1 minus 3 or -4. So therefore, the solution of the system is -3, -4. Example of real-life problems that can be solved using systems of linear equations. The admission fee at a small fair is 15 pesos for children and 40 pesos for adults. On a certain day, 2,200 people enter the fair and 50,500 pesos is collected. How many children and how many adults attended? Solution. Let X be the number of adults, Y be the number of children, 40X be the amount generated from adults, 15Y be the amount generated from children. So for equation 1, we have to add X and Y. So X plus Y equals 2,200. So this is the number of adults and children. For equation 2, 40X plus 15Y equals 50,500. This will be the amount collected. Solve by substitution method. Equation 1 is X plus Y equals 2,200 and equation 2 is 40X plus 15Y equals 50,500. Step 1. Using equation 1, X plus Y equals 2,200, we solve for Y. So we have Y equals negative X plus 2,200, which now becomes equation 3. Step 2. Substitute equation 3, the value of variable y in equation 2. So again, equation 2 is 40x plus 15y equals 50,500. So substitute y, which is negative x plus 2,200. That's why we get 40x plus 15 times the quantity negative x plus 2,200 equals 50,500. Step number 3. Solve for x. So 40x plus 15 times negative x is negative 15x. So we use the distributive property. So 15 times 2,200, we have positive 33,000 equals 50,500. And then combining like terms, 40x minus 15x is 25x plus 33,000 equals 50,500. And then solving for x, so we need to apply here addition property of equality. So we need to add negative 33,000 to both sides. So that's why we get 25x equals 50,500 minus 33,000, and we get 25x equals 17,500. And then to finally solve for the value of x, so we need to divide 25 to both sides. So that's why we get x equals 700. So 700 was obtained from 17,500 divided by 25. Step 4. Solve for y in any of the equation. So in here, we use equation 1, which is x plus y equals 2,200. So substitute x by 700. So we have 700 plus y equals 2,200. And then subtracting 700 from both sides, so we have y equals 2,200 minus 700. Therefore, the value of y is 1,500. So for checking, x is 700 and y is 1,500. For equation 1, x plus y equals 2,200, x is being substituted by 700 and y by 1,500. So 700 plus 1,500 is really 2,200, which is correct. For equation 2, 40x plus 15y equals 50,500. So substitute x with 700 again and y with 1,500. 40 times 700 is 28,000. 15 times 1,500 is 22,500. When added, we get the same result. We have 50,500, which are equal. Therefore, there are 700 adults and 1,500 children who attended the fair. Now, kindly answer learning task number 2, 3, and 4 in your math notebook for practice. That's all for now, and thank you for listening.